Hi guys, welcome again to a new question, that is printing all primes till n. Now let us understand what the question wants. In the question it is written you have to print all prime numbers between a range. Okay, that means to say, for example, from 5 till 50. So, okay. Now take as input low, the lower limit of range. So in that example of 5 to 50, we'll have low as 5. Okay, take as input high, the higher limit of range, so 50 will be the high limit. And for the range, print all the numbers, prime numbers between low and high. Okay, great. So the input format should be low and high, and the output format will be the numbers between them, which are primes. So basically we need to take in inputs, so we need to utilize the scanner command. Now we are more or less familiar with the scanner command. So scanner scn is equal to new scanner system.in system.in. Okay, I'm spelling system.in. Okay, and the two inputs are low and high. So low and high. Now what does this do? That will take a low input as low and an input as high. So basically we are getting a range. But how do we know its range? We need to run a loop which will go from low till high. How? N plus plus. And basically we don't need this end because I have initialized int in the first case only here. So I don't need this int. Okay. Now I'm printing the output, and that is I'm printing the numbers. Now let me run. My input is say 10 and the or say 550, so 5 and then 50. So I am running again. That is coming at 5, 6, 7, 8, 9, 10, 11, 12 till 50. Okay, so I'm getting all the numbers from 5 to 50, but that is what I didn't intend to do. I needed only the prime numbers, but here I'm getting all the numbers. So for that, I need to check something. I need to count the prime numbers. I need to find out the prime numbers. So how do we do it? You did the previous question, right? Wherein we needed to check if a number is prime or not. And from that question, we saw that we have to make two optimizations, or we need to take care of two things. One, for counting factors, we need to start from 2 and only go till the square root of that number. That is our first optimization. And the second optimization is whenever we find a factor other than 1 and the number itself, that is, we are basically taking into account that we have two factors or more than two factors. So whenever we are running a loop from 2 till that square root of that number, and if we find any other factor, so basically our factors increases and will break out and then print that this number is not prime, as we did in the previous question. So let us do this. How? I'm writing int count equals 0, and then we'll check for the factors like in the previous question we did int fact starting from 2. Okay, and then fact into fact less than equal to n. Why? because we need to check till the square root of n. So square root of n is not writable here, so I'll do factor into factor till n and then fact plus plus. Now if same as the previous sum of previous problem, n factorial n mod fact equals 0, then we need to increase the count as 1 plus plus, and then if we get another count, then we need to break out, because we don't need to further check for other counts. Like if we got 2 as the factor, then we need not check for 3, 4, 5 and 6, because we are getting an extra factor other than 1 and that number. So basically it signifies that the number is not prime. So why do we need to go for other means checking other factors? We are satisfied here only that this number is not prime. So we'll break out from that loop, and after that we'll system.out.println wait. Then if we get the final count as 0, then this signifies that this is a prime number. So we have to write n here, because if the prime number is there, then we need to print the number. Otherwise we don't need to print anything. That is, we need to skip the non-prime numbers. Okay, so I've written this, and let me check. Okay, since the range was 5 to 50, the output is 5. Okay, 7, 11, see 6 is excluded, 8 and 9, even 10 is excluded because these are not prime numbers. 11 is a prime number, so it is included. 11, 13, 17, 19, 29, 31, okay, till 47 we have got, and the rest numbers are non-prime numbers, therefore they have been excluded. So basically we see that our solution is accepted, and we are more or less sure that this is the most optimized solution. So let me submit and check if all the test cases have been filled. So I'll submit it. And hooray, I get 10 out of 10. So that means all my test cases have been fulfilled. Okay. So did you get the understanding of how to print all prime numbers between a range? Hopefully, yes. Thank you for tuning in, and wait for the next lecture. Thank you.